We'll start with the, so in the previous class we discussed regarding the introduction to the timers along with the counters. We will discuss regarding the T-mode registers along with the T-code register. So in this class we'll see the modes of programming, that is the mode 1 programming along with the mode 2 programming. So this mode 1 programming, it is a 16-bit timer programming. So therefore it allows the values of the 0000 to the FFFF to be loaded into the timers registers TL along with the TH value. So after loading this TL along with the TH value, so you should start the timer by using a set bit TR0 or set bit TR1 instruction. So after that, the next step is, so after loading the initial value, after starting the timer, it should start counting up. It counts up until it reaches the maximum value of the FF. So once it reaches a maximum limit of FFFF, it rolls over from the FFFF to the 0000H. So after that, it sets the timer flag equal to 1. So when the timer overflow flag is equal to 1 means the timer need to be stopped. Next step is, after the timer reaches the limit and it rolls over, so in order to repeat the process, so you should reload the value. So you should reload the TL along with the TH value into this register and the timer flag must be reset. Next is steps to programming the mode 1. So first step is, so you should load the T-mode value. You should load the T-mode value which indicates that which timer and in which mode it is operating. So whether it is operating under the mode 1 configuration or the mode 2 configuration, and whether you are going to make use of the timer 0 or the timer 1. So that will be decided based on what the value you are going to load into the T-mode register. The second step is, so you should load the TL along with the TH register with the initial count value. After loading the T-mode value along with after loading the TL along with the TH value, the third step is you should start the timer. So how to start the timer means by using a set bit TR0 for timer 0 instruction, set bit TR1 for timer 1 instruction. So next is the fourth step. After starting the timer, so you should keep monitor the TF. The TF stands for the timer overflow flag. How to monitor the timer overflow flag means by using the JNP TFX target instruction. JNP stands for the jump if the direct bit is not set. If the timer flag, if it is not equal to 1 means, so you should jump to a label target. You should remain in this loop until the TFX becomes equal to 1. So once it becomes equal to 1 means you should come out of the loop. The third step is, so after the timer overflow flag is set to 1 means, so when it is set to 1 means, then it rolls over from the maximum to the 0. So in that case the timer flag will be set to 1. So once the timer flag is set to 1 means you should stop the timer. How to stop the timer? By using the clear TR0 if it is a timer 0 instruction, clear TR1 if it is a timer 1 instruction. So next step is, so you should clear this timer overflow flag for the next round. So after that, so in order to repeat the process, so you should reload the TL along with the TH value. That means, so you should go back to the second step. So these are the steps what you are going to follow in case of the programming, in case of the mode 1. So next we'll some of the formulas related to this timer programming. So in order to calculate the time delay, the formula will be the maximum count value minus initial count value plus 1 multiplied with the 12 divided by the crystal frequency. So if you are going to connect a crystal frequency whose frequency is 11.059 megahertz means, so in that case the time delay is equal to the FFFF minus YYXX plus 1 into 1.085 microseconds. So this 1.085 microseconds, it depends upon the what is the crystal frequency you are going to connect to the 8051 microcontroller. If it is 11.059 megahertz means the time period will be equivalent to the 1.085 microseconds. So if the frequency changes means then this time period also varies. So this formula, it is in terms of the hexadecimal. So if you want to calculate the time delay in terms of decimal calculation, means in that case the time delay will be equivalent to the 65,536 minus n multiplied with the 1.085 microseconds in terms of the decimal. So if you are going to make use of the 16-bit timer, means the maximum count value will be FF. If it is an 8-bit timer, means in case of the mode 2 configuration, the maximum count will be FF. In case of the decimal, it is 256. So next formula is to calculate the initial count value. What the value you are going to load into the registers. For that, the formula will be the maximum count value minus time delay into the crystal frequency divided by 12 plus of 1. So next we'll see some of the problems. First problem is write an assembly language program to generate a 50% duty cycle. 50% duty cycle means it is nothing but a square wave in which the on period will be exactly equal to the off period on the P1.5 bit. So you should use a timer 0 in the mode 1 to generate the delay. Along with that, you should calculate the amount of the time delay generated by the timer. And you should assume that crystal oscillator frequency is 11.059 megahertz. So this is a problem. So in this case, the first step is, so you should load the initial value to the T-mode registers. So in that case, you should mention which timer and which mode it is operating. So in this case, you should make use of the timer 0 in the mode 1. Since it is a timer 0, you should make use of the lower 4 bits. Since it is a mode 1 configuration, the T0 bit should be equal to 1. So in the case of the T-mode register, you are going to load the initial value 0, 1. So after that, you are going to load the initial value to the TL0 along with the TH0. The initial count value what you are going to load into the TL0 is F2. In case of the TH0, it is FF. Since in this problem, it not mentioned the frequency of the square wave. So you are going to consider you can consider any of the value what you are going to load to this registers. So in this problem, I am going to consider the value in the TH0, I have loaded the value FF. In the TL0, I loaded the value F2. So after that, I am going to complement this P1.5. So where I need to generate the square wave, I need to generate the square wave on the P1.5. So if suppose this P1.5, initially if it was a 0 means, then it will complement to the 1. The square wave consists of the on period along with the off period. So whatever may be this P1.5, that bit I am going to complement it by using a CPL instruction. CPL stands for the complement. Which bit I am going to complement? P1.5. So after complementing that bit, so it should remain in that time period for some interval of time. For that purpose, I am going to call the delay by using a call delay. A call stands for the absolute call delay. So this is the name of the subroutine. I am going to call a subroutine program called as a delay. So after that, the control of the program will be transferred here. So this is a delay program which is generated by using the timers. So in the delay program, the first is I am going to start the timer. How to start the timer? By using a set bit TR0. So why it is TR0? Because I am going to make use of the timer 0. So I am going to start the timer. So after starting the timer, I am going monitoring this timer overflow flag by using a jump if the direct bit is not set. It will remain in this loop again until this timer overflow flag will be equal to 1. That means once we have loaded the initial value FF2 into the TL0 along with the TH0 register. So after that, it starts incrementing from this initial value to the next value. The next value is FF3. So it reaches the maximum value. So once it reaches the maximum value, it rolls over from the maximums to the 0. So in that case, this timer overflow flag will be set to 1. So once it is set equal to 1 means you are exited from this loop. So after that, so you should stop the timer. How to stop the timer? By using the CLR instruction TR0. CLR stands for the clear the timer start bit, timer uncontrol bit, that bit you should clear. After this, you should clear this timer overflow flag. So in order to repeat the same process, you should clear this timer overflow flag. then return instruction. So the control of the program will be transferred here. So after that SJMP here, where is the here label? The here label is here. So after this again you are going to load this initial value. Again you have to complement. The previously the P1.5 is in the logic high state, then it should turn on to the logic low state. Then it should remain in that interval for some delay. So this process you are going to repeat it so that you are going to generate a square wave on the P1.5 with equal on period along with the equal off period. So next we'll see for the same problem how to calculate the time delay. So the frequency is not given in the problem. So in order to calculate the time delay, the formula is maximum count value. Maximum count is nothing but final value minus the initial value plus 1 multiplied with the 12 divided by crystal oscillator frequency. So in this problem you consider the frequency as 11.0592 MHz. So it is 12 divided by 11.0592 MHz. The final value, since the timer is a 16-bit timer, the final value or the maximum count value will be FF minus initial value. What you are going to load into the TL0 along with the TH0 register, it is FF2 plus 1. So if you simplify this, you are going to get the time delay of the 15.19 microseconds. So here the time delay will be generated either by considering the on period or by considering the off period. For this entire time period, the total time delay generated will be equal to the twice of this. It is twice into the 15.19 microseconds. That will be equivalent to the 30.38 microseconds. So there is one more method to write the same program, so without using a subroutine program. So in this way also you can write down the same program. So next we'll see the second problem. The second problem is find the delay generated by the timer 0 in the following code. So they are already given the subroutine program, delay subroutine program, which is generated by using the timer. For this you should calculate the time delay. So how to calculate the time delay? We know the formula. The time delay will be equivalent to the maximum count value minus initial value multiplied with the crystal oscillator frequency divided by 12. The maximum count, since it is a timer 0, the maximum count value, timer 0 in the mode 1 configuration, the maximum count value will be FF minus the count value. The count value is this B83E. FF minus B83E multiplied with the F divided by 12. So in the crystal oscillator frequency, we'll assume that it is 11.0592 MHz. It is 11.0592 MHz divided by 12 will be equivalent to the 1.085 microseconds. So if you simplify this, the result will be 19.931 milliseconds. So this is the delay generated by this timer 0 subroutine program. So next we'll see the third problem. The third problem is with the frequency of the 22 MHz, generate a square wave of frequency 100 kHz on the pin P2.3. Use timer 1 in the mode 1. So in this problem, he had mentioned the frequency of the square wave, what you need to generate on the pin P2.3. The frequency is 100 kHz. And here the crystal oscillator frequency which is connected to this timer is 22 MHz. And you should make use of the timer 1 in the mode 1. So you need to generate a square wave with a frequency of 100 kHz. So the time period will be reciprocal of this frequency. That will be equivalent to the 10 microseconds. And whenever you are going to generate the delay will be generated either by considering the on period or by considering the off period. The total time period T is equal to T on plus T off. That will be equivalent to 10 microseconds. So T on plus T off will be equivalent to the 10 microsecond by 2 will be equivalent to the 5 microseconds. And here you are going to connect the crystal oscillator's frequency is 22 MHz. So time period of this clock will be 12 divided by 22 MHz. That will be equivalent to the 0.546 microseconds. The count value, how you are going to calculate, will be the delay generated by this timer divided by the time period of the clock of the crystal oscillator frequency. So it is 5 microseconds divided by 0.54 microseconds. That will be equivalent to the 9 cycles. So next you are going to calculate how to load the count value in the TL1 along with the TH1. That will be equivalent to the maximum count value in terms of the decimal is 65,536 minus the cycles what you are going to get by dividing the delay by this time period of the clock, that is 9. If you simplify this, you are going to get the 65,527 In terms of the hexadecimal, it is FFF7. So next we'll see the program. So in the program, initially you're going to load the value 10 to the T mode register. Why it is 10 means you're going to make use of the timer 1 in the mode 1. So whenever it is a timer 1 in the mode 1 means you're going to make use of the upper 4 bits and the D4 bit should be equal to 1. So next you are going to load the initial count value in the TL1 along with the TH1. So it is F7 along with the FF. Then start the timer by using set bit TR1 because it is a timer 1. So after that you go on monitoring this TF1 until it becomes 1. You will remain in this loop again. So once it becomes 1, you are exited from this loop. When it becomes 1 means when it reaches a maximum value. Maximum value is FFFF. So when it reaches a maximum value, it rolls over from FFFF to the 0. So after that, this timer overflow flag 1 will be set to 1. So once it is set to 1 means you are exited from this loop. So next is you should stop the timer by using a clear TR1 instruction. So next is you should complement this P2.3. Initially the P2.3, it can be in the logic high state or in the logic low state. Since you should generate a square wave, there should be equal on period along with the off period. So you should complement the P2.3. Then you should clear this timer 1 overflow flag in order to repeat the same process. After that, SJM to pack. Again, the initial count value will be loaded into the TL1 along with the TH1. Again, you have to start the timer. So monitor that TF1. Then stop the timer, complement this. So this process you are going to repeat it since you need to generate the square wave continuously. So next we'll see the fourth problem. The fourth problem is generate a square wave with an on time of 3 milliseconds and off time of 10 milliseconds on all the pins of port 0. So you should assume the crystal oscillator's frequency is 22 MHz. So in this you should generate a on time of 3 milliseconds, off time of 10 milliseconds on all using all the pins of the port 0. And you should assume the crystal oscillator frequency of 22 MHz. So first we'll see how to calculate the initial value which is loaded into the registers. First we'll consider for the off time. For the off time, so you should, for the off time the time delay is 10 milliseconds. So it is 10 milliseconds divided by 0.546 microseconds. So this is the time period of the crystal oscillator what you are going to connect. It is 22 MHz. You are going to consider the crystal oscillator's frequency is 22 MHz. It is 12 divided by 22 MHz. That will be equivalent to the 0.546 microseconds. So for the off time, it is 10 milliseconds divided by 0.546 microseconds. That will be equivalent to the 18,315. The maximum count value will be, the count value in order to generate the off time of 10 milliseconds will be maximum count minus this. It is 65,536 minus 18,315. That will be equivalent to the 47,221. In terms of hexadecimal, it is B875H. Similarly, for the on time, it is 3 milliseconds divided by 0.546 microsecond. It is 5,494 cycle. To calculate the value, it is 65,536 minus 5,494. That will be equal to the 60,042 in terms of decimal. In terms of hexadecimal, it is EA8K. So you should assume that timer 0 in mode 1. They are not mentioned which timer and in which mode it should operate. So in this problem, let us assume that timer 0 in the mode 1. So you should generate a on period of with a delay of 3 milliseconds, off period with a delay of 10 milliseconds. So let me see the program. So in the program, initially you are going to load the 01 to the T mode register because it is a timer 0 and the mode 1. So let me start with the off time. So in case of the off time, you need to generate a delay of the 10 milliseconds. So what is the value you should load? So for the off time, so you should load a value of the 75 to the TL0 register, B8 to the TL0 register. So where you should generate the square wave, you should generate the square wave on all the pins of the port 0. Since it is a off time, so in the port 0, what you are going to move? You are going to move an immediate data 00. After that, you should give some delay. So you are going to call a subroutine program a call delay. So the control of the program will be transferred here, and the subroutine program, it is started with the location of 300H. So in the subroutine program, initially you are going to start the timer by using a set bit TR0 instruction. Then you go on monitoring this timer TF0 overflow flag by using a JNB TF0 instruction. It will remain in this loop again until it becomes 1. So once it becomes 1, so you should stop the timer by using clear TR0 instruction. Then you should clear this timer 0 overflow flag, return. So the control of the program will be transferred here. So then you should generate a on time with a time delay of 3 milliseconds. For that you should load the initial value. The initial value is 88 in the TL0, EA in the TS0. Then you should generate the on time with a delay of 3 milliseconds. Since it is a time period is high, in the port 0 you are going to move an immediate data FF. So after that you are going to call a subroutine program by using the A call delay. So the control of the program will be transferred here. Again the same procedure will be repeated. So after that the control of the program will be transferred to the main program SJMP back. The same process will be repeated. That is continuously on period with a delay of 3 milliseconds, off period with a delay of 10 milliseconds. Continuously a pulse will be generated with the on period along with the off period. So next we'll see the mode 2 configuration. Still now we are discussed with the mode 1 configuration. The mode 1 is a 16-bit timer operation. Mode 2 is a 8-bit auto reload mode. So in this mode, it is an 8-bit timer mode. So therefore it allows the values of 00 to the FF to be loaded into the timer register TH. You are going to load the value to the TH register since it is an 8-bit. So after loading the initial value to the TH register, so you are going to copy that TH value into the TL register. So after that you are going to start the timer by using a set bit TR0 for timer 0 instruction, set bit TR1 for timer 1 instruction. So after loading the value, then after starting the timer, it should start counting up by incrementing this TL register. So after that, once it reaches the maximum limit of FF, it rolls from the FF to the 00. So after that, it will set this timer overflow flag to the logic 1 state. So after that, this TL value, it is reloaded automatically with the original value kept in the TH register. So you should not, so in order to repeat the process, just you need to clear this timer overflow flag, and it continues without any need by the programmer in order to reload the original value. So it is called as a auto reload mode. So you did not load the value again into the TL register, so that will be done automatically. So it is called as a 8-bit auto reload mode. Steps to program in the mode 2. The first step is you should load the T mode value indicating which timer and in which mode. Second one is you should load the registers TH value. The same thing will be copied to the TL register. Then you should start the timer. Next step is you should keep monitor this timer overflow flag by using a JNB TFX target instruction. Jump if the direct bit is not set. Where you are going to jump? You are going to jump to location target. So once it becomes 1 means you will come out of that flow. So next step is you should clear this timer overflow flag for the next round. So in the mode 2 you did not stop the timer. So just you need to clear the timer overflow flag for the next round. Then again go back to the step 4. Because this mode 2 it is an auto reload mode. We are not going back to step 2. Directly we are going to the step 4 because the values will be loaded automatically since it is a mode 2 configuration. So next we'll see the problem in case of the mode 2. With the frequency of the 22 MHz, generate a square wave of frequency 20 kHz on the pin P2.5. You should use a timer 0 in the mode 2. So you should generate a frequency of the square, you should generate a square wave with a frequency of 20 kHz on the pin P2.5, and you should assume the crystal oscillator's frequency is 22 MHz, and you should make use of the timer 0 in the mode 2. Since you need to generate a square wave with the frequency of 20 kHz, the time period will be 1 divided by f, that will be equal to the 15 microseconds. The total time period is equal to t on plus t off since it is a square wave. So therefore t on along with the t off both will be equivalent to the total time period divided by 2, that will be equivalent to 25 microseconds. Since you are going to, whenever you are going to generate the delay, you are going to consider either an on period or an off period. Here you are going to consider crystal oscillator whose frequency is 22 MHz. So the time period of the clock will be 12 divided by 22 MHz. That will be equivalent to the 0.546 microseconds. The count value will be the T on period or T off period divided by the time period of the crystal oscillator frequency. It is 0.546 microseconds. If you simplify this, you are going to get the 46 cycles. The count value, what you are going to load into TH registers will be the maximum count value. It is 256 minus 46. That will be equal to 210 in terms of decimal. In terms of hexadecimal, it is T2H. So let me start the program. So in this program, you want to load the 02 to the D-mode register because you want to make use of the timer 0. Since it is a mode 2, the D1 bit should be equal to 1. Then you want to load the initial value in the TH0 register. The initial count value is T2H. After that, you are going to start the timer by using set bit TR0 because you want to make use of the timer 0. Then you are going to monitor this timer 0 overflow flag by using a JNB TF0 to the back label. That means it will remain in this back label until this TF0 becomes 1. So once it becomes 1, you are exited from this loop. After that, you are going to complement this P2.5 because you need to generate the square wave. Initially, if the P2.y, if it was 1 means it will be complemented to the 0. If it is 0 means it will be complemented to the 1 because you need to generate the square wave. So after that, you are going to clear this timer 0 overflow flag. Then SJMP back. Here we are not loading the, we are not again reloading the value in the TH0 register because it is a auto reload mode. That value will be automatically, the initial count value will be automatically loaded to the TH0 along with the TL0 register.